and that's Spark Machine Learning. So we have a chance to get a quick look at how Spark ML works. So in this example, we're going to again look at a data set that I have here in S3. Here I'm running a head command so you can see what that data looks like. It's a data set from the R kind of universe of a bunch of diamond sales. And for each diamond, we've got properties about that diamond, like the carat weight, the color, the clarity, the shape of the cut. And what we're trying to do here is predict the price. So you can see that for each diamond, we have a price. It's actually in US dollars in this data set, even though it doesn't say it here. And what we'd like to do is kind of take a look and see whether we could use Spark to model the price of a diamond as a function of these other numeric parameters here. We're going to use just the numeric parameters to keep things short and simple for today. Of course, if we were doing this for real or in the longer class, we would make sure we use all of the data available and we could build a better model. So up above, I just did a Linux head command. That's not Spark code. Here I'm going to run a Spark command, and I'm switching over to Python. So Spark allows you to mix languages. And in this case, I'm going to shift to Python because, you know, in the machine learning world, pretty much everyone is using Python or R. And honestly, I don't know very much R. So if I were doing this in R, I wouldn't be very effective. So I'm going to focus on Python here. And this is a similar command to what we did earlier for creating a data frame that's derived from this data file and looking at some of the rows on the screen. So now Spark has access to this data. So for our simple example today, we want to look at the price as a function of the numeric predictors here. So we're going to look at carat weight as a predictor of price. We're also going to look at the other numeric predictors, which are, or some of the other numeric predictors, which are the dimensions X, Y, and Z. So X, Y, and Z are sizes in millimeters of the diamond. And so we're going to grab the carat, the price, and the X, Y, and Z values, and we'll see if we can use those to predict the price. So this is another command that just says, hey, I want a query that pulls up these columns. And if we're doing some data science, we might want to, especially a linear model, we might want to do a scatter plot to see what's going on here. So this is a scatter of carat versus price, just to kind of see how that works. Now, before we can build a model, we need to assemble all of the predictors or features into a single feature vector. So unlike scikit-learn and pandas, where your features or predictors are in separate columns, in Spark, they all have to be in a vector in a single column. And that may change in the future, but at least for now, that's the way it works. So we're going to use a built-in helper called vector assembler to collect the numeric columns together and create a new column called features that contains a vector of these features. So this assembler is a feature engineering or feature processing helper that's built into Spark alongside lots of other feature engineering pieces that help us transform our data to prepare it for modeling. So if you do machine learning, you know that the kind of cliche is that 80% or 90% of your work is actually data cleansing and processing and engineering work before you get the fun part of building the models. And so Spark has a number of tools for that, and this vector assembler is one of those. So I'll show you what the vector assembler does by taking the assembler and calling .transform, because the assembler is a thing called a transformer in a pattern that is modeled after scikit-learn, but doesn't work exactly the same way. So again, in the longer classes, we explain how the API patterns work in Spark in terms of transformers and estimators, how they're similar to other systems like scikit-learn, and how they're different. In this case, I'm using this transformer called a vector assembler to transform my data frame, and that's producing a new data frame that has this features column over on the right. So if you see on the right here, there's a column called features, and it has a vector full of double values. Spark always does its machine learning modeling over vectors of doubles. Okay, well, we have a feature vector here, so let's grab a linear regression algorithm. We can go and instantiate that and tell it that what we're trying to predict, the label, lives in a column called price. And then we're ready, almost ready to do our modeling. We want to do a training test split because we want to make sure that we have some held out test data to use to see whether our model is any good. If we don't hold any data out, we'll never be able to tell whether our model generalizes or not. So I'm going to use a built-in helper called random split to create a training and a test set. Then I'm going to add the vector column to the training set, and I'm going to take the linear regression and fit it against that data, and that's going to give me a linear regression model. And then to make predictions, which I'm going to do on the test data, I'm going to take that linear regression model, and in Spark, all models are actually transformers, and I'm going to transform the vectorized test set here. So now what we should get is a model and then a set of predictions. So here you can see that I've got an output data frame that has a prediction column. It looks like some of these predictions are maybe not that great, like a negative $29, but in any case, we've now built a model on Spark and we've used it to make predictions. So it's a little different from what you might be used to if you usually use, say, scikit-learn or R or something like that. But you can also see it's not too hard, right? It only took us 4 or 5 lines of code to start creating a model, and then from here we could refine it and try and build something better for the business. Now, one thing you may have noticed in there that was a little awkward is how I had to kind of process the training set and then process the test set, and I kind of had to nest these calls, and you might imagine that that could get kind of awkward if I had 20 or 30 feature engineering steps, which is not uncommon. And so Spark includes another abstraction which is borrowed from the scikit-learn world called a pipeline. And the pipeline's even easier to use. The reason I didn't show it to you before is because I wanted to give you a little bit of a look at kind of the basics, what's going on under the hood. But the easier way to do this in general is to create a pipeline that tells Spark what stages you'd like to use, in this case, a vector assembler, then a linear regression. And because all of the Spark transformers and estimators work exactly the same way, Spark knows what to do with those things. And it allows us to say pipeline.fit, and Spark knows what to do with the assembler, namely to transform the data, and what to do with the linear regressor, namely to do a fit, in order to produce a pipeline model. So pipelines, which are themselves estimators, are kind of an encapsulation of a series of feature engineering and model fitting tasks. So now I have a pipeline model, and I can do a slightly simpler version of model.transform to generate predictions.